it's manageable. So guys, what we're going to do today is we are going to actually go back in time, and we are going to revisit the last 2 labs that we did. You may remember that during the last unit, we did that lab where we decomposed silver oxide, heated it up in the crucible, collected the silver, figured out the atomic mass of silver. Then guys, in the next lab that we did, we took magnesium and we burned it up, and we collected the magnesium oxide, and we figured out the empirical formula for magnesium oxide. Now guys, the reason that we're going back to both of these labs is calculation number 1 in both of those labs. Do you remember? You don't need to look, but do you remember what calculation 1 was in either or both of those labs? Write a balanced equation. And you may want to write this down with me just so you have the experience. So, and you'll notice I left you some note space, write small. So guys, what I did, let's say the empirical formula lab, I got up in front of you and I said something like this. I said, guys, today what you're going to do in lab is you're going to take some magnesium. And I said, then what you're going to do is you are going to react that magnesium with some oxygen, and we are going to collect the product. And then, guys, it got even more interesting, because then what I said is, what does this make? And we said magnesium is +2 and oxygen is -2, so our product is MgO. But then we said, hey, don't forget, oxygen bonds to itself, so this is an O2, but because there's 2 oxygens there, there's got to be 2 there, but we get 2 there by doing this, which then gives us 2 magnesiums, which means we've got to do this, and then we just move forward. Guys, today what we're going to do is we are going to answer a bunch of questions, and we're going to teach you how to do this. And we're going to talk about things like this. Why the 2? Why is there a 2 there? And then we're going to talk about this. Why is this MgO and not MgO2? And then we're going to talk about this. Why did there need to be a 2 there? And why couldn't we just put the 2 there? And then we're going to talk about why is there a 2 there and not a 2 there, even though there's a 2 there. And we are going to teach you how to do these today. And guys, all of that is what is called writing balanced equations. Now guys, understand there's actually 3 concepts there that we need to address. We are only going to talk about 2 of them today, and the third we'll do on Friday. So guys, these are the background things that you need to understand, and you just want to get this in your notes. So if we're going to talk about balancing equations, we need to know what a chemical equation is. So scratch it in your notes. And again, guys, I've given you space, but you're going to have to use it conservatively. So guys, chemical equations are the things that we use to represent chemical reactions. So for example, the thing that I wrote on the board in blue represented the reaction that took place in your crucible during the second lab. So they're sentences, if you will, that describe chemical reactions. So guys, when we write chemical equations, they have 3 fundamental parts. We have the part on the left, which are called the reactants. Then guys, we have an arrow. And we read that arrow as the word yield, and then we have products. So when we write chemical equations, we say that reactants yield products. Now guys, the trick is this, and we need to make sure you're clear on this. The reactants don't have to be on the left, and the products don't have to be on the right. We can write them either way. So how do we always know which one's the products? The arrow will always point at the products. So whether we write it left to right or right to left, the arrow will always point to the products. Okay, so now we know what chemical equations are, we know their parts, we know what they do. Now guys, we need to dig into some of the details that we need to understand before we really start balancing these things. So guys, the next thing that we need to talk about then are diatomic molecules. I got to go get in periodic table laser position. Okay, so here we go. So guys, let's talk about diatomic. What does the prefix di mean? 2. And atomic, of course, means atom. And what does molecule mean? What kind of bonding? Nope, that's a salt. Covalent. So guys, these are 2 atoms bonded together covalently. And I'm not going to give you that because I figured you could come up with it. If you don't know that, you might want to write it down. So di means 2, atomic is obvious, and then molecule means covalently bonded. And so guys, the bottom line is this. There are some elements that are so reactive that when they're by themselves, they bond together with another one of the same atom. And you already know one that does that. Which one? Oxygen. Oxygen, you already know, does this. But it's not just oxygen. There are 7 of them. So guys, these are the molecules that are composed of 2 of the same atom, and they are these 7. Iodine, bromine, chlorine, fluorine, nitrogen, and oxygen. These are the 7, and hydrogen. These are the 7 diatomic molecules. So guys, you will never see these 7 atoms by themselves. They will either be bonded to something else or they'll be bonded to each other. So again, it goes iodine, bromine, chlorine, fluorine, oxygen, nitrogen, and hydrogen. And again, guys, these are the diatomics. These are the guys that bond together in packages of 2. So they'll either be bonded to something else or they'll be bonded to each other. Now, guys, the bottom line is you got to memorize this. But check it out. You actually don't. Look at where they are at on the periodic table. So here's what you do. Start at iodine and go up until you can't go up anymore. Then go left until you run out of red things, and then jump to the only other red guy on the periodic table that's to the left, which is hydrogen. So again, guys, it makes an inverted L and then a hop to hydrogen. So iodine, bromine, chlorine, fluorine, oxygen, nitrogen, and hydrogen. So if you can just remember that shape on the periodic table, you don't have to memorize them. You'll just know which ones they are. You good on that? Okay. Now, guys, continuing with the foundational stuff that you need to know until we can actually start balancing equations, the next thing we need to do is remind ourselves of the law of conservation of mass. Yeah, it's a good question. So why is astatine not diatomic? And actually, the reason is because it's so big. We'll talk about it. So remember, Mason, for covalent bonds to form, there has to be attraction and sharing, right? But as we go down the periodic table, they get bigger and therefore weaker. And it turns out that astatine is so big that it actually can't form covalent bonds even with another astatine. So astatine actually is I got to be careful with only, but I think it's only found in salts. Because it doesn't covalently bond very well. Because remember, for a covalent bond to form, both of the atoms have to be strong enough that they can't be stolen from, so they share. And astatine's so big and weak that it just gets stolen from. Does that make sense? Okay. So guys, now the last, well, not quite the last thing, but the next to last thing we need to do is remind ourselves about the law of conservation of mass. Do you guys remember what it says? Matter is never created or destroyed, right? It never goes away. So guys, you're going to find out that this is the reason that we've got to put the numbers in front of the molecules when we balance equations. Because if matter is never created or destroyed, then everything that goes into a reaction has got to come out of the reaction. So the bottom line is the number of atoms of reactant must equal the number of atoms of product. If those aren't the same, then your equation isn't balanced. All right, so guys, now you've got your toolbox full of the things that you need to know in order to write balanced equations. You know that equations have a reactant side, a product side, and a yield arrow. You now understand that there are these things called the diatomics, and you've got to look out for those because they'll never be alone. If they're not bonded to something else, they'll bond to each other. And now you understand that when we balance equations, the number of atoms that go in and the number of atoms that come out have got to be the same, because that's the law of conservation of mass. You guys groovy? Okay, so now guys, we're ready to start balancing equations. So what I'm going to do is I'm going to give you some steps for balancing equations. And then we're going to do the examples that are there at the bottom of the page. And then, guys, you're going to have a lot of time for homework today, because the way to get good at this is to do these. So, guys, step number 1 is this. The first thing that you do when you write a balanced equation is you identify the reactants and products. What is reacting together and what is being produced? Now, guys, here's the trick. You don't know enough about chemistry right now to figure out what is reacting and what is being produced. So we're going to do this next time. We are not going to get to the point where you'll be identifying reactants and products. Yeah? They are, but you're right. But so you know which ones they are, but you don't know specifically what they are. So if I told you that aluminum sulfate reacted with powdered iron, what does it produce? You have no idea. You know that there are going to be products, but you don't know what the products of any particular reaction would be, and that's what we're going to talk about next time. So then, guys, step 2. Write the chemical formulas for the reactants and products. So now you're saying to yourself, wait a minute, if I don't know what the reactants and products are, how can I figure out what their formulas are? And the answer is, I'll give them to you. So this we're going to do in just a minute. We write these by balancing their charges, and we don't try to balance the equation. And guys, I know that doesn't mean anything to you right now, but you're going to try to get ahead of yourselves. When you write chemical formulas, you are only trying to balance the formulas. You're not trying to balance the equation. And we're going to do this in just a minute. We're going to do this later, in about 15 minutes. And then, guys, finally, step 3 is to balance the equation using coefficients. Coefficients are the large numbers that we were writing in front of the formulas for the reactants and products. And guys, that's where we're going to start. We're going to do that first. And we're going to work our way today and then on Friday up this set. So basically what it means is as you get deeper into this, I'm going to give you less and less help. So at first, I'm going to give you everything you need and you just balance them. Then later today, I'm not going to give you the formulas. And then on Friday, I'm not even going to give you the products. And you are going to have to progressively stay on top of this. Now guys, while we're talking about progressively stay on top of this, some of you, and I'm just talking from my heart here, guys, some of you, it's clear, don't understand the idea of stay on top of this. That was very evident given that last test. And I think you would agree that what you found is that last unit just backed up on you. The very first day we figured out formula masses. And if you couldn't do that, you couldn't do anything else, but a lot of you just blew that off and said, I'll figure it out later. And then we did dimensional analysis, and some of you said, I'll figure it out later. And then some of you said, I don't really worry about moles conversions, I'll figure it out later. And eventually what you figured out is trying to figure things out later kept you from figuring out the new stuff, and you couldn't figure anymore. And I tried to warn you, but some of you didn't heed my warning. Okay, so let me come back to this again. Don't let this slip past you. This is going to be another very cumulative thing, and if you can't do what we're doing now, you'd better get help, because this doesn't get easier, and in 3 days, it turns back into dimensional analysis. So guys, please be careful, get on top of this quick. So, guys, with all of that said, let me see if I can make this process easier for you. When you're balancing equations, these can get a little tricky. So here are some helpful hints. Guys, helpful hint number 1 is this, and it means nothing to you, but it will in a minute. When you are balancing equations, try to balance the polyatomics intact if you can. What does that mean? I'll show you in a minute. But it'll make your life a whole lot easier. Hint number 2 is this. If you get what I like to call an odd-even conflict, because odd numbers and even numbers will never balance, what do? Well, take the odd number and multiply it by 2, and the algebra gods will smile down on you, and they will magically turn that odd number into an even number, and then they may balance. Math magic. So guys, if you run into this odd-even conflict, double the odd number of atoms and then try again. Hint number 3 is this: balance oxygens last. Oxygen shows up all over the place. Oxygen is tricky because it's diatomic. Balance that last. Then guys, hint number 4, when all else fails, try brute force. Guys, if you can't get an equation to balance, plug in a 1 for the very first atom. See if you can get it to balance from there. If not, erase and try a 2. And if that doesn't work, erase and try a 3. But guys, in order for you to be able to take advantage of this idea, what have you got to do? Be able to erase. And you can't do that if you're working in pen. So guys, my last advice to you would be do these in pencil. Do not try to balance these equations in pen. You're quickly going to get really frustrated. So guys, do these in pencil. Okay, so guys, here's the way the rest of the day is going to go down. First of all, I want to make sure that you understand balancing equations conceptually, so I'm going to do it for you visually. Josh noticed there's a pant load of slides in today's presentation. It's not because there's a lot of material. You're done taking notes. All the rest of the slides are the animation that you need to see in order to understand how balancing equations works. Then what we're going to do is we are going to do these together. All of these. Then guys, with the remaining probably 30 minutes in class, you are going to have time to not make the same mistake that some of you made in the last unit and let this back up on you. So we're going to have a very productive 30 minutes, and we're going to make sure that you know how to balance equations. So guys, balancing equations visually. How does this work? Well guys, this is the equation that we are going to balance. Don't write any of this down. Just watch. So guys, we are going to take this equation and we're going to balance it. So let's talk. Why is O O2? It's diatomic. And then guys, what is this? Carbon dioxide. It's a gas. It goes off into the room. What is this? Water. And then guys, does anybody know what C3H8 is? Then let me tell you this. Guys, this is actually the chemical reaction that takes place when you cook your cheeseburgers on your Weber grill. Guys, C3H8 is propane. And the other product that comes out of this is heat. We'll talk about that more later. But guys, this is propane. And every good Boy Scout knows that in order to get something to burn, you need oxygen. What you may not know is that when you burn propane in your grill, it forms carbon dioxide. And where does the carbon dioxide go? Out of the grill. But guys, it also forms water. And where does the water go? It boils off. It's so hot inside of there that it boils off. But guys, if you could collect the water that is formed when you cook like half an hour on your Weber grill cooking burgers for dinner, you actually produce about a cup of water. There's a lot of water that is actually coming out of your grill. So much so that some people have actually tried to collect it. Because this not only happens in your Weber grill, this actually happens in your car as well. Because, guys, the only difference between this that happens in your Weber grill and what happens in your car when you burn gasoline is actually C8H18, which is called octane. Ever heard of it? Octane ratings for gas. You guys know about this? When you buy your gasoline and it says 85, 86, and 88, you know the 3 buttons you can choose? Guys, that is actually telling you the amount of octane that's in your gasoline. It's not a percentage. It's different than that. But guys, the bottom line is what you're doing is just burning a CH compound that's got more carbons and hydrogens. But our military actually, do you guys know about this? That our military actually collects the water that comes off of their Humvees and they have the soldiers drink it. You guys know? Yeah. So like when we're fighting like in the desert, because a lot of what we're doing right now is in the Middle East, which is a desert and there's no water, they have actually put condensers right before the muffler of the Humvees that are running around in the desert. And as the water comes out of the tailpipe, as it's coming out of the engine, they actually have a condenser that condenses the water. They put it through a carbon filter so it doesn't taste nasty. And there's a water tap on the side of the Humvees. And so when our soldiers get thirsty, they can come and fill their water bottles, and the water is actually the water that's condensed off of the Humvees running. Oh yeah, it's pure water. Yeah, absolutely, it's pure. You guys know? You didn't know? Anyway, okay. So guys, we've got a problem though. Let's come back to propane. The problem is that we violated the law of conservation of mass. Because how many carbons are going in? 3. How many are coming out? 1. Where'd the carbon go? We'll talk about it in a minute. How many hydrogens are going in? 8. Coming out? 2. Uh-oh. But then look here. We've got 2 oxygens going in. How many are coming out? 3. 2 plus 1. So we're losing carbon, we're losing hydrogen, and we're making oxygen. No, we're not. We just don't have the ratios right. So guys, let's get the ratios right. So this is what this reaction looks like. The blacks are carbons, the blues are hydrogens, the reds are oxygens. So this is a molecule of propane, this is a molecule of oxygen, this is a molecule of carbon dioxide, this is a molecule of water, and now you can see that what's going in is not what's coming out. So what do? Well guys, we start on the left and we work to the right. So how many carbons do we have here? 3. Carbons here? 1. So what do? And guys, the answer is this. We put a 3 in front of the carbon dioxide. We don't put a 3 down here. Guys, let's make sure you're clear on this. The 3, oh boy. Come on. So guys, the 3 does not go. Just a second. All right, let's go here. Let's try this. Let's go back here. Let's do this. And now let's see if I can draw. Okay, there we go. Okay, so guys, again, the 3 does not go here. Why does the 3 not go there? Because that means we created a new compound. We just made a carbon, 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 oxygen, oxygen compound. 3 carbons and 2 oxygens. And that don't exist. So guys, in order for us to get 3 carbons, what we actually need is 3 carbon dioxides. So now we've got 1 carbon there, 1 carbon there, 1 carbon there. That's how we get 3 carbon dioxides. It's multiples of the molecule, not changing the formula. So now our carbons balance. We've got 3 carbons here, 3 carbons there. So now let's do hydrogens. How many hydrogens do we have there? 8. How many do we have here? 2. So what are we going to do? Put a 4 in front. Uh-oh, hold on. This is not behaving well. Guys, what we're going to do is we are going to put a 4 in front of the water. So now we have 2, 4, 6, 8 hydrogens that match the 8 hydrogens right here. You get it? So now let's do oxygens. We've got 2 here. How many do we have in total on the right? Well, we've got 3 times 2, which is 6. 1, 2, 3, 4, 5, 6. We've got 4 times 1, which is 1, 2, 3, 4. 6 and 4 is 10. So what are we going to do over there? Put a 5, and now this balances. So 3 molecules of propane, 5 molecules of oxygen, 3 molecules of carbon dioxide, and 4 molecules of water. You get the idea? Okay. So guys, what you've got to be able to do is the same thing without the pictures. So we're going to do these together. Hi. Oh, heavens, no, that's fine. You're not in there this period though, right? Okay. So guys, you've got to be able to do this without the pictures. And so I'm going to step you through this. And you guys know me well enough to understand that these are in a very specific order. Guess what order they're in? Not easiest to hardest. The same as the hints. So guys, let's go through them. You ready? Starting on the left and starting on the left for each one of these, here's what we do. How many carbons on the left? 1. How many carbons on the right? 1. How many hydrogens on the left? 2. How many hydrogens on the right? 2. How many oxygens on the left? 1. How many oxygens on the right? 1. This is balanced. Oh, did I say copper? Sorry, it's carbon. So guys, this is balanced. 1 copper, 2 hydrogens, 2 hydrogens, 1 oxygen, 1 oxygen. This is balanced. So why do I bring it up? Because this is wrong. Guys, 1s are understood. You don't put 1s in front of the formulas. They are understood to be there. In the same way in algebra, where x means 1x, the 1s are understood, and so we don't put them down. Okay, so now let's go down to number 2. This is where this gets a little more challenging. So here we go. Aluminum's on the left, 1. Aluminum's on the right, 1. Now guys, watch. Nitrogen's on the left. And it's at this point, guys, that you need to see something important. Yes, this is nitrogen, but that nitrogen is tied up in a polyatomic ion, which I think you know to be nitrate. So now you ask yourself this question. You say, okay, this nitrogen is in nitrate. And I could balance the nitrogens and the oxygens, but can I balance the nitrates? And the question then becomes, does it stay intact? So here we've got nitrate, and there we've got nitrate. So guys, that means instead of balancing the nitrogens and the oxygens, we can balance the nitrates because they stay intact. So guys, how many NO3s do we have? 3. How many do we have over here? 1, so we need 3. So we put a 3 there, and now we have 3 nitrates. Now guys, let's go to the next element. The next element that we see is sodium. How many sodiums do we have on the left? 1. How many sodiums do we now have on the right? 3, because this is 3 sodiums, so now we need 3 here, so we need a 3 in front of the sodium. Now we move on, and we look at the oxygen. But guys, looking at the bigger picture, we see that this oxygen is a part of the polyatomic hydroxide. Hydroxide is OH. So now we ask ourselves, can we balance the polyatomic? Is it intact? Well, let's see. Did the OH stay together? And yes, it did. That means we can balance the polyatomic intact. So how many hydroxides do we have over here? 3. And how many do we have over there? And we're done. Do you get it? So guys, now let's go down, and please ask questions if you need. But guys, let's go to the next one. Here we go. So down here we've got 1K, 1 potassium on the left. How many on the right? 1. Now guys, watch. Here we've got NO3 nitrate. just like in the previous question. But can we balance nitrates? You cannot, because the nitrate did not stay intact. It became NO2. And because the NO3 became NO2, you can't balance NO3s because they don't exist in the product side. So now we have to balance them as individual atoms. So how many nitrogens here? 1. How many nitrogens there? 1. Now, guys, check this out. Now we need to balance oxygens. How many oxygens do we have on the left? 3. How many oxygens do we have on the right? 4. What do we got? Odd-even conflict. We've got 3 oxygens on the right. We've got 3 oxygens on the left, 4 oxygens on the right, and those will never balance until we make them both even. So guys, what we're going to do is we are going to take the source of the odd number and make it even. We do that by doubling it. But now we've created a problem. Do you see it? And we now have 2 potassiums and 2 nitrogens, which means we've got to go back and rebalance everything. So now we've got 2 potassiums, so we need a 2 there. Now we've got 2 nitrogens, which keeps the 2 there. And now we've got how many oxygens on the left? 6. 3 times 2 is 6. Here we've got 4 plus 2 is also 6, and it balances. Questions on that? You okay? Okay. Now, guys, let's go down here and let's try these last 2. So it goes like this. We've got 1 iron on the left, and we've got 2 irons on the right. So we will put a 2 there. Now, guys, we've got 2 hydrogens on the left and 1 hydrogen on the right. Or I'm sorry, 2 hydrogens on the left, 2 hydrogens on the right. So we're good there. And now we've got 1 SO4 here. And we've got, oh wait, can we balance the SO4s intact? They stay together. So we've got 1 SO4 here. How many SO4s do we have there? 3. So we put a 3 here, and now it's balanced. We already balanced the hydrogens. Right. And guys, you've got to be careful because as in the previous question, sometimes balancing one thing will mess up something you already balanced. So it's always good to go back and check because now we have 6 hydrogens here, but only 2 there. So we need a 3. So now, guys, let's do the last one. Look at your first to last, well, not first to last, your third rule. What is it? Do oxygens last. We're going to do oxygens last. Guys, if you tried to balance the oxygens first, this gets complicated. Do it last. So we've got 1 carbon, 2 sulfurs, 1 sulfur, so we need a 2. Now we can balance the oxygens, and we've got how many on the right? Total of 6, which means we need a 3 here. Now, guys, the thing that we did not go over was that first to last rule that says if all else fails, just strong arm the thing. And guys, what I mean by that is this. Say that this first one, and we know that it balances with all 1s, but guys, say that you get into the middle of this first one and you're like, good stinking night, I can't get this to balance. Well, here's what you do. Throw a 1 in front of the very first substance and then try to balance it from there. When that fails, throw a 2 in front of the very first substance. Try to balance it from there. If it works, great. If not, throw a 3 there and just keep trying until you find a number that will create a situation where you can get it to balance. Yeah. That's a good question. And like I say, I would always stick by that do oxygen last. So I would start hucking numbers not in front of oxygen. That's a good question. So, guys, questions on the fundamentals of balancing equations? You're okay? Go ahead, Josh. Correct. Yes. Yep. Absolutely. And it doesn't have to be that way, but it's just the way we read. So it just works better. You guys okay? All right. Now, guys, we are going to climb up the ladder. So what we have now talked about is this. This is right out of your notes. We just talked about balancing equations using coefficients. Now, guys, what we're going to do is we are going to go up a spot, and you are now going to balance these equations when you're not given the formulas for the reactants and products. On Friday, I won't even tell you what the products are, but for today, you're just not going to be given their formulas. It reads like this. You've got this down at the bottom of your page. We're going to do it together. It says calcium metal reacts with copper 1 sulfate to produce calcium sulfate and copper metal. What you're being asked to do is write the balanced equation. So guys, let me help you be successful with this. Here's what you want to do. Well, first of all, this. Give yourselves a lot of space. Guys, when we start getting into this homework in just a minute, you've got to do this on clean, big, empty sheets of paper. You need space. Because here's the first thing you're going to do. Draw an arrow right in the middle of your page. The first thing you've got to do is get organized. And guys, the way you get organized is you organize your thinking around a yields arrow. And so when we draw the yields arrow left to right, where will the products be, on the left or the right? The right, because the arrow points at products. And now, guys, we go back and we read again, and here's what you're going to do. Every time you read a chemical, you're going to ask yourself two questions. What is it and where does it go? Is it a reactant or is it a product? And then what is it? So this says calcium metal reacts. And guys, the fact that it is reacting tells you it goes on which side? The left, because it's a reactant. And now, guys, we need to know what calcium metal is. And guys, calcium metal is just Ca. So why does it say calcium metal and not just calcium? Well, guys, look where calcium is. It's on the left. So what does that make it? A metal. It's redundant. It could have just said calcium, but they're reminding us that it's a metal. So then we're going to write a little plus sign, and then we're going to go on. And we continue to read. And it says reacts with copper 1 sulfate. So if it's reacting with copper 1 sulfate, where does copper 1 sulfate go, left or right? On the left. It is a reactant. Now we need to know what it is. So copper is Cu, and that's +1. Sulfate is SO4, and that's -2. So we need 2 coppers and 1 sulfate. So this is Cu2SO4. Guys, you're going to be writing chemical formulas for the rest of the year. And again, and I know I keep coming back to this, clearly from the last test, some of you don't know how to write chemical formulas. We need to work on that, guys. Please come and get help. Okay. Now, guys, we continue to read, and now we see this magic word that says to produce. That means everything that comes after that is products. So our first product is calcium sulfate. We already know that, well, we know that calcium's Ca. We know that sulfate is SO4. This is +2. This is -2. So we need one of each. So that would be CaSO4. And then, guys, it says and copper metal. And copper metal is just Cu. And now you're going, wait a minute. That's Cu, but we've got 2 coppers on the left. So do we make this Cu2? No, why not? Because copper is not diatomic. Iodine, bromine, chlorine, fluorine, oxygen, nitrogen, and hydrogen. Copper is not diatomic. So now you're going, wait a minute, but then the equation doesn't balance. That's fine. You're not trying to balance the equation. Guys, you got to hear this. You're not trying to balance the equation yet. You're just trying to get the formulas right. So that 2 does not belong there. Now we balance the equation. So it's just like what we did before. 1 calcium, 2 coppers, 1 copper. So we need a 2. Can we balance the sulfates in place? Does it break apart? No. 1 SO4, 1 SO4, and we're done. So guys, there you have it. You have half an hour. And guys, you have a lot of work to do. These are not easy. What you'll find in this homework packet is that the first section of these, you're given the reactants and the products. You'll notice that I spaced things out generously. You can balance those right on the paper. But then, guys, down here below where you're writing formulas and balancing these things, guys, grab another sheet of paper. Don't even think about trying to do it on here. Give yourself space. So I would love to help in any way I can. The last 5 minutes of class, I'm going to hand your test back to you. Guys, you're welcome to work with other people, but this is going to be highly productive time. Go ahead, Lena. Do you want me to just come and talk with you? Okay. So guys, go get them. You've got everything you need.